Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Stefan for Business Review, and I'll be your host. It is our pleasure to have Donaldson Company with us today, who will be presenting this webinar titled Sustainability and Regulatory Compliance Benefits of Connected Dust Collectors. Today's guest speaker is Brent Nelson, Global Products Manager at Donaldson Connected Solutions Division. Before we begin, I'd like to welcome you to the webinar platform ON24. You will notice that this webinar is browser-based. In case you happen to disconnect for any reason, please just click on the link you receive via email to rejoin the session. In order to ask questions, you can do so via the Q&A widget on the top right-hand side of your screen. Just type your question into the box and click Submit. We will allocate some time at the end of the session to address any questions or thoughts that you may have. Please use the yellow Help widget if you require any assistance, and keep in mind you can move, resize, and maximize any of the windows in front of you for a better view of the slides. But now, please allow me to welcome Brent.
Thank you, Stefan, and thank you everybody for joining today on this Monday afternoon, or potentially Monday morning, or potentially Monday afternoon, depending on where you're dialing in from. So today's topic is going to focus on a connected dust collector, and I think. If you've got dust collection in your company, you deal with dust collection in any way, you're going to find something beneficial in this discussion. You're going to learn something in this discussion. But we are going to have a heavy focus on sustainability and compliance aspects of dust collection management. So just before we get started, a little bit of an overview on Donaldson. So Donaldson is a technology-led filtration company. We're over 100 years old, and filtration has always been at the heart of what we've done for the last 100 years. Donaldson has essentially two divisions. We've got an engine division, which primarily builds filters, air filters, fuel filters for vehicles, for off-road, construction, ag, military, wide variety of vehicles. And then we've got the industrial side of the business. And the industrial side of business does a wide range of filtration in factories and industrial facilities. Obviously, we're talking today about dust collection and industrial air filtration, but there's also filtration for water, steam, compressed air, hydraulics. So you're probably using Donaldson products somewhere in your factory, even if you're not aware of it. So we are a little over $2.5 billion company that is a global company. We've got offices all over the world. Okay, so our agenda today, we're going to kind of start with the basics. We'll talk about what a dust collector is and what it means to connect a dust collector. And then we'll talk about, the first big topic we'll talk about is how to track and manage your energy consumption. Because we have a sustainability focus today, obviously that's a big concern. Whenever we talk about sustainability, one of the first things you talk about is how do you track and potentially reduce energy consumption and greenhouse gas uses. Then we'll talk about compliance management and reporting for anyone who has any type of regulations around dust collection, either now or in the future, and you've got to track and report that data for compliance reporting. And then the last topic will be how do you track and manage emissions? So how do you understand that what's coming out of the exhaust of your dust collector is relatively clean and that you're not potentially polluting either your internal work environment or the outside environment? A little bit more about myself. Stefan introduced me. I'm Brent Nelson. I'm a global product manager in Donaldson's Connected Solutions division. And the Connected Solutions division is a little different from other groups at Donaldson where we don't build and sell filters or filtration equipment directly. Our focus is on building solutions and services for customers based on connecting and getting data from those filters and those filtration machines at the edge. I am the global product owner for Donaldson's IQ Connected Filtration Service, which is a solution for capturing data from dust collectors and then sending the data up to a web-based dashboard. So we'll reference that a little bit throughout the discussion. A little more about my background. I actually spent about 12 years prior to coming to Donaldson in the IoT space building wireless devices, wireless technology, platforms, and solutions on IoT. So I've been involved in IoT for a long time, and I've been at Donaldson for about 3.5 years now. Initially started out as an electrical engineer. Okay, we're going to start with a poll. Just to give me a little background, you can go ahead and start filling this out. But how familiar you are with dust collection equipment? And I'll give you a few seconds, and I'll talk while you're filling that out. I'm sure we've got a wide range of people, from ones who really don't deal with that equipment at all and aren't real knowledgeable to people who are really experts in dust collection. And we're going to start with the basics and move through to some more advanced concepts. So I think wherever you are on the scale, you will find something beneficial today, but it helps me to understand, kind of what general level of knowledge we have with this audience. So I'll give it about 10 more seconds for people to fill that out. Let's take a look here. All right, so we've got nobody not at all familiar. That's good. So we've got slightly familiar, somewhat. We kind of have the board, but everybody's got some familiarity with dust collectors, so that's good. And we've got a few experts on here, so we'll get in some of those advanced concepts that you'll find interesting. All right, so now, as I said, we'll start with the basics. We'll start with what is a dust collector and what is a dust collection system, but then we'll talk about what does it mean to connect a dust collector. So here's a very basic overview of a dust collection system. Obviously, the dust collector itself is in blue, but we're going to focus not just on the dust collector. We're going to talk about the whole dust collection system today and how to optimize and manage and monitor that system. So if we start with the lower left, you'll see those are your capture points. So those are your hoods that are pulling dust away. Wherever dust is generated in your factory, those hoods are pulling dust away from either the machine that's generating the dust or the workers who might be in that area. It's pulling that. And in this case, we're showing a system with 2 drops. Now, you might have a system with 1 drop. Really large dust collectors might have 50 to 100 drops. It really varies on the size of the dust collector itself. That air is then pulled through the ducting into the dust collector where it goes across the filters. So that's where the particulate is captured by the filters and filtered out to have at least relatively clean air exhausting out of the dust collector. Now, just about every dust collector is going to have some type of cleaning mechanism on the filters. In most cases, and what we're going to talk about today, are ones that use compressed air. So they have compressed air that shoots across the filter, it knocks that particulate off the filters, and it's going to fall down into some type of collection drum or some type of collection system, in this case represented by the black drum at the bottom. And as those filters start to collect more and more particulate, even though they're cleaned, over time, they will build up resistance to airflow. And the longer the filters run, the more resistance they have and the harder that fan has to work. And that's why the most common thing tracked on a dust collector is the differential pressure. You hear it called pressure drop. That's how much resistance those filters are providing to airflow over time. And that's why it's typically the most common data point that's captured from a dust collector. But we're going to talk about a lot of other data points that can be captured. So as air continues to move, it passes through the blower or the fan, and then it's exhausted out of the discharge duct as emissions, either inside your factory or outside your factory, which we're going to talk a lot about in the next few slides. And then when we talk about dust collection management, we always talk about it in terms of the 3 E's. So you see exposure, which is really what level of dust are the people at the collection points or the machines at the collection points exposed to, how efficiently is your dust collector working, and then the emissions. How clean is the air that's actually coming out of those emissions? We're going to have a heavy focus on emissions today, but we'll kind of reference all 3 as we go. Yep. So what we see in the industry when we go out and look at people and look at their dust collectors, what we see is, the dust collector is not the machine that makes you money. It's not the machine that's creating, packaging, and pushing your product out the door. And because it's not directly a revenue-generating machine, it's often a secondary priority when it comes to maintenance. And a lot of people are very reactive with their dust collector maintenance and inspection and really struggle to keep those machines running. And that's not to blame anybody. Everybody knows we've got that there's limited resources out there. It's difficult to hire people. Everybody's got maintenance budgets and engineering budgets, and there's only so many people you can have. And those challenges all existed in a pre-COVID world, and COVID has really flipped that on its head. So it makes sense in some ways to prioritize the revenue-generating machines, but typically if your dust collectors aren't working, then those revenue-generating machines aren't working, and those people can't be in those areas. So in some ways, they're every bit as important. And we see a lot of the negative outcomes that happen when dust collection, maintenance, and monitoring is ignored. And it spans the gamut of a lot of different things, from unexpected production downtime, excessive labor, lots of cost of ownership. But the three that we're going to focus on today is the increased energy consumption costs, increased emissions, level of particulate that's coming out of the stack, and then the possible risk of regulatory fines and penalties, either if you are in an industry that's regulated either from OSHA or EPA or some other local body. So we know that just hiring more people is not a solution to improving how you manage your dust collectors. We just talked about in the last slide. So what is the way that you can improve and have better dust collector management and monitoring? And the answer is connectivity. So this all kind of falls under the umbrella of Industry 4.0. Industry 4.0, not in any way a new term. It's been around for decades. It's a way to connect factory assets, to get more data in real time from those factory assets, to allow you to better control, manage, and monitor those assets, whatever those assets may be. So you can see in real time what the machine is doing. You can get alerts if something's not working correctly, and you've got historical data available to help you debug and optimize your processes. Now, there's two ways to connect machines. Now, what I call it the traditional way is through the traditional control systems. These are on-premise systems. They've been around for decades. You're probably using them all over your plants. And they're capturing tons of data from your production line, driving it to a local system that's on-premise. And these are completely closed off, very complex systems with very low latency, so they can do all the control applications. The other way to monitor assets, which is relatively new, is using the cloud or the Internet of Things. And this is a different solution where the data is captured from the machine and then doesn't touch your control systems, doesn't touch your local networks. It's actually sent to a cloud and then exposed to the users through a web-based dashboard. So this is relatively new, and these two systems are not in any way competing against each other. They serve different uses in the plant, and we'll talk about IoT really represents an easy way and a good way to monitor dust collection systems. But as I said before, dust collectors are very often a secondary priority when it comes to maintenance and engineering. They're also a second priority when it comes to connectivity. So most often when we go out and look at customer sites, we see dust collectors that aren't connected in any way. And so what we most often see is the filter log. And this is a picture I took at a customer site. And this is the way that a lot of our customers will still monitor and manage dust collectors. Somebody manually writes in a handwritten value, usually differential pressure, but it might be other values, once or twice a day. And then at the end of the week, somebody grabs those clipboards and they type it into an Excel sheet, and now you've got your historical data should you need that for any compliance reporting or any other purpose. This is still the most common way that we see people managing dust collection systems. So there's a lot of drawbacks for that, obviously. First of all is the labor time it takes to actually go out and do this. If you got a small factory, maybe it's not a big deal. We've got customers that are factories spanning many acres. People spend a lot of time going out and manually recording that data. And it can also be a safety hazard as well, because if you've got people, maybe they're walking on icy sidewalks, maybe they've got to climb ladders, go up to roofs, maybe they've got to go into hazardous areas, it can actually be a safety concern for those workers. The even bigger piece is you're not getting any real-time data. Obviously, this is not coming in real time, and it's not helping your maintenance teams move to any kind of a condition-based maintenance where they're trying to be proactive of their maintenance and react quickly and getting alerts when things are wrong. So your maintenance stays completely reactive when this is how you collect data. And obviously, it's prone to mistakes or lost data. If you can't read somebody's handwriting, if you lose a sheet, if somebody didn't fill it in, there's a lot of possibilities for lost data. And of course, there is the possibility that somebody's not purposely fabricating the data. Hopefully that doesn't happen, but with data that's used for compliance purposes, that's always a concern. Now, we do see people using traditional control systems for monitoring dust collectors. And while this is obviously a big step up from using a paper log, there's some drawbacks for that approach as well. Typically, when I see customers who are using a traditional control system, they're really only getting a couple of data points, usually differential pressure or something else. They're kind of doing the bare minimum that you would need to do to monitor a dust collector. The other drawback of traditional control systems, especially when it comes to dust collection systems, is traditional control systems are extremely closed off. They're extremely secure. Data does not leave the factory. Data does not come in from outside the factory. And that's the way those systems have to operate, because you can never risk somebody outside your organization getting access to your control system. The drawback for that, especially when you get to something like dust collection systems where you see maintenance is frequently outsourced and support for dust collectors are frequently outsourced to dealers, service companies, maybe the OEM where you purchase the dust collector from, those outside companies can't access any of that data from your control system. You have to keep it closed off from them. Now, an IoT solution works different because it pushes data to a secure cloud. It's still secure. Nobody can just log in and see your data. But because it's web-based, it makes it easier to share that data with third parties with your permission, so that service company that helps you service dust collectors, help you support them. If there's a problem, you can call them up. They can take a live look at the data that's coming from your dust collection system and help you debug that problem faster. And so in a recent survey, just to back up this point, half of Donaldson customers said they don't get any alerts when a dust collector is not working properly. So they're really at a break fix or a purely reactive maintenance and engineering approach to dust collection systems. So that's something that we can certainly improve on. All right, so we talked about it a little bit, but let's talk about how connected filtration service works. And I'm going to use IQ service as Donaldson's IQ service as an example. So the service has a gateway that connects to the dust collector. It has a variety of sensors for pressure and airflow built into it, and it also has the capability to connect to external sensors, to wire and external sensors. So you can sense a lot of different data points from the dust collector. That data is captured and it's sent to the cloud over a secure cellular link. That's where the data is stored. And then it's exposed back to the users through a web-based dashboard. So the web-based dashboard is going to show you data in real time, status in real time of your dust collectors, showing you if there's any alerts. It's available anywhere you've got internet access through a browser. It's available on your phone, your tablet. And then it also has alerts built into it, so you get alerted if something is not working correctly. You get weekly status reports from that, and then you can also graph and download the data from that if you need to use that to help debug any issues or optimize your system or for compliance reporting. Now, obviously, this data is available 24/7. It's available from anywhere. You can see data from dust collectors in all your plants. If you've got multiple plants, all from one dashboard. So it makes it very easy to manage from small to a very large number of dust collectors. And as I said, we allow, if a user chooses, they can allow outside parties to look at that data as well. Again, if you're relying on a service company or a dealer, an OEM for support, they could also look at that data and help you debug issues or help you with your service needs. So let's talk a little bit about what the IQ filtration service tracks. As I said, most people who are tracking data manually have one data point, and it's differential pressure. If they're connected to a traditional control system, it might be 2 or 3. But there's actually a lot of data you can get from a dust collector that can be beneficial. So these are the basics. So it's the differential pressure, airflow, compressed air pressure. But there's a lot of additional data points. So the stuff in gray are additional sensors that you can add, everything from temperature and humidity of your airstream to pressure of your HEPA differential pressure, tracking what level the particulate is in your bin. And then we've got energy monitoring coming out in just a few months, and we're going to talk about that a little bit coming up in a later release. So there's a lot of data that you can get from a dust collector that will help with your monitoring and managing of it. Okay, so now we've got an overview of what a connected dust collector is. Let's talk about tracking and managing your energy consumption of the dust collector. So obviously dust collectors can be big consumers of energy. Since we have a sustainability focus today, we're going to talk a lot about how to manage and potentially reduce and track that energy reduction. So when we talk about reducing energy usage of a dust collector, or at least monitoring energy usage of a dust collector, it really comes down to 3 things. One is, how are you exhausting? Are you exhausting the air inside or outside? Using a VFD on the blower, and then lowering your compressed air usage. And we're gonna dive deep into these 3 topics in the upcoming slides. So the first one is exhausting inside versus outside. So you've probably got dust collectors in your facility already. They're probably either wired up. Some are probably exhausting inside. Some people may be exhausting outside. There's a lot of things that go into that decision, and you will probably be sometime in the future adding dust collectors and have to go through that same decision. Do we vent the air outside, or do we have it come inside? And as I said, there's a lot of things that go into that decision. We'll talk about that in a couple slides. But one of the things you should consider with that is energy usage. So if you're exhausting outside the plant, all the air that's getting exhausted outside must be made up with air coming into the facility. And that air has to be conditioned just like any other air. So in cold climates, you've got to heat the air. In warm climates, you've got to cool the air. In Minnesota, we seem to get the extremes of both. Lots of heating in the winter, and then we've just had a couple of 90-degree weeks here, so lots of cooling. And this leads to a significant cost in energy usage of reconditioning all that air when you're exhausting outside. So here's an example calculation. I hit one more here. You'll see it, the calculation is down there in the bottom. That calculation based on how often you run the dust collector, what your CFM is, what the degree days is, which is to keep it quick, just a calculation of where above and below normal temperatures you are based on number of days. The calculation you actually see is for energy, but you can change that calculation and put in the EPA estimate for metric tons of CO2 used per barrel of oil to actually calculate the energy cost. So in this calculation, we're looking at a 10,000 CFM dust collector. And the picture you see on the right, that's a Donaldson DFE. That's a dust collector that would be typically used for about 10,000 CFM. So you can see it's not a massive dust collector. It's not a small. It's really kind of in the middle. We're looking at a factory with 5 collectors that's running 2 shifts and 6 days a week. So that's kind of also a typical factory, kind of a medium-sized factory having 5 medium-sized dust collectors. So this is by far not a worst-case type of calculation. This is really trying to do a typical calculation. So if those 5 dust collectors are exhausting outside in Minnesota, just on the heating side, we don't know about cooling because it'll make it too complicated, but just on the heating side, the energy cost of heating that makeup air is $126,000. So that's what you would save if you were exhausting inside. And from a greenhouse gas estimate, it would be about 700 metric tons of greenhouse gas. So we're talking about a significant change when you're changing, depending on how you're exhausting that air. Now, energy usage is certainly not the only thing you've got to consider when you're talking about exhausting inside versus outside. In fact, if you look at the Industrial Ventilation Manual, they've got a whole decision tree here, which you see on the right, and I'm not going to go through all the decisions. And depending on what you're filtering and depending on what the regulations around it, venting inside might not be an option in any way. If it's highly toxic, if it's carcinogen, if there's really low contamination or concentration ratings required by OSHA, it might not be even a possibility. But there's a lot of things that you should consider, but I want to make sure that you have the data to say energy usage should be a big consideration of how we're venting that air and whether we make some kind of change, or at least when it comes to dust collectors you might be purchasing in the future. But the other thing to consider is when you're exhausting inside, the impact of any dust collector issue is magnified, because now if your particulate level rises significantly because of, say, a broken filter or filter bypass, excess dust is going right into your factory. So it's potentially polluting the air your workers are breathing. It might be contaminating your machines or process, and it might just lead to a dirty plant. So we're talking about connectivity here, and if you're going to exhaust inside, connectivity becomes an even more important thing, because you really need to understand when that dust collector is not working well, because the impact of any problem is greatly magnified. So really increasing the criticality of getting the data in real time and getting alerting. And really the important piece is when exhausting inside, you need to know the differential pressure. You need to know where those filters are. As they get older, the pressure drop is going to increase. So you need to know when those filters are getting older, when they need to be changed, and when you before any type of failures happen. When you're exhausting inside, there's typically going to be a secondary filtration stage, which is typically going to be a HEPA filter on the exhaust. So monitoring the differential pressure on that is also important. So when that's starting to get plugged up and when that's a potential cause of failure. You want to monitor the particulate trend that you're exhausting. So if that's going up and you're potentially contaminating the air inside your factory. And you want to track airflow so that you've got sufficient airflow, that airflow is not dropping because maybe your filters are getting so plugged up that your fan can't keep up. You need to get alerted on that and make sure you're getting proper filtration inside that facility. So, as I said, lots of things to consider. It's not just energy usage, but I want you to have all the information available when making those types of decisions now in the future. All right, so the second thing we'll talk about is a VFD. Obviously, VFDs have been around for a long time. Their energy savings and how they save energy is pretty well known. Lots of VFD calculators out there and claims. But when it comes to dust collectors, the way the VFD really works is as those filters start to plug up, the VFD will start to work harder to make sure that you still have sufficient airflow going through. So when you've got relatively new, relatively clean filters, that VFD can turn its power level way down and still maintain the proper airflow. As they start to plug up, that VFD will work harder, more power, and pull that air through. So there's really two benefits from it. You get the energy savings with new filters because it's not working as hard. But then when the filters start to get dirtier, you still get designed airflow. The VFD is making up for it. So they provide really two different benefits. We're going to focus on the energy usage. And the energy savings itself can vary widely depending on how big the dust collector is, what the particulate is, how dirty the filters are. Anywhere typically from 20% to 50% energy savings you can expect. But of course, as those filters start to plug, that VFD is going to work harder, and you're going to start to lose that energy savings. So if we look at it from a calculation standpoint, we go back to the previous example of 5 dust collectors that are rated for 10,000 CFM. The energy cost savings of a VFD versus non-VFD on those 5 dust collectors would be about $22,000 and 180 metric tons of greenhouse gas for the 5 collectors across the year. So it's not as significant of a savings, but again, it's a much easier change than changing how you're exhausting a dust collector. Because installing VFD is a pretty straightforward, pretty well-known approach. But, and this life always comes with a but, if you're not monitoring that VFD, and if you're not changing filters, and if you're not monitoring your differential pressure, you're going to lose any of that energy savings. Because as those filters get dirty, now that VFD's got to ramp up, and you're going to increase power usage 20 to 55%. And if you look at the table on the right, this comes right out of a fan curve for the fan that would typically draw about 10,000 CFM. And so the first column you'll see is how much airflow it's going. So we're keeping consistent airflow. The second column is the static pressure seen by the fan. So you see about a 4-inch of water increase in static pressure seen by the fan, which is roughly the difference between clean filters and dirty filters. A 4-inch of water increase of pressure is pretty typical going from clean to dirty filters. And then if you look, the next column over is kilowatt hours, and lastly is the increase. So if you're running with dirty filters, now you've increased your power use to about 52%. So any savings you would have got from installing the VFD are gone. And so this, again, brings up the importance of not just installing the VFD, but monitoring that in real time. So you know when your differential pressure is rising, when your airflow is falling. You can actually track in real time what your energy usage is and track over days and months and see how is that energy usage changing as my filters clog. And you can track fan capacity, so you know, am I starting to get to the capacity limits of my fan because those filters are building up so much pressure that I need to do a filter change before my fan becomes unstable. So what we're really doing here is we're giving you the additional data to try to balance those filter change intervals, because the maintenance teams, the engineers, procurement, they want to get as much time out of those filters as possible to avoid the cost and the effort of changing filters. But as we just saw from an energy management standpoint, that's actually the worst strategy. So now you've at least got the data on both sides. You can look and optimize those filter change intervals. Doesn't mean you can change filters every week. That's not reasonable. But there's a balance in there between changing, pushing that change date out as far as possible, but also managing and knowing when am I using so much energy with those dirty filters that I'm better off changing the filters earlier. Okay, last one we'll talk about from energy usage is compressed air. So I said most dust collectors have some type of cleaning system that utilizes compressed air. Compressed air is a significant source of energy use in any facility. So this is another thing you'll want to track. Now, most dust collectors will have differential pressure rises on those filters. It will hit a cleaning set point, and now it starts cleaning. It will clean down to a low set point and stop cleaning. That's called on-demand cleaning, which is how most people do cleaning. But as those filters start to age, it's harder and harder to clean the dust off those filters because the dust gets embedded in the filter, and you've got to clean for longer and use more compressed air as those filters age. So the older the filters are, the more compressed energy you're going to use. So here's a real-world example. We can actually track how often a machine is pulsing in IQ, which you see in the bottom right. That's an actual screenshot from IQ tracking the pulses on this dust collector. And so we monitored this on a dust collector at our factory over a 6-week period. And using on-demand cleaning on what were pretty clean filters at the time, it pulsed 9,000 times. Now, if it had been continuously cleaning, which is pulsing all the time the dust collector is running, it would have used 108,000 pulses, so 12 times significantly more compressed air used to clean those filters. And what you've got to know is, as we talked about, when those filters get really plugged, those on-demand cleaning times get longer and longer until it actually gets to the point that you're just cleaning all the time. And I've talked to customers, and I say, how do you know when to change your filters? They say, well, because it never stops cleaning. It's cleaning all the time. That's how we know that those filters need to be changed. So on-demand cleaning, if it's not monitored, the filters aren't changed, eventually becomes continuous cleaning, and you're wasting a lot of compressed air. So they said energy use 12 times higher with plugged filters with on-demand cleaning than it would be with relatively clean filters. Again, that's something you can monitor with our IQ system. It'll show you how often that is pulsing. You can track those changes from week to week to month to know how that's changing as your filters age. Okay? So to kind of sum up the energy usage section, kind of that old adage, you can't improve it if you can't measure it. And the other point is you can't prove that you improved it if you can't measure it. Obviously, when it comes to sustainability, you want to not only improve, but you want to prove that you've improved it so that you can hit those goals. So measuring the fan energy, what's the power usage in real time? What's the daily or weekly energy used, and how is that trending over time? How is that changing? And then monitoring the compressed air to know how often are you pulse cleaning, and how is that changing as your filters age? And then kind of going back to our discussion about outside versus inside, it's really critical in any scenario that you're getting alerts when anything in the dust collector is not working properly or has hit its limits, whether that's differential pressure, airflow, compressed air being out of range, or something else like your bins are overflowing, your hoppers are plugged. You need to get alerts on those so that you can move from a purely reactive maintenance into a condition-based maintenance and potentially even a predictive maintenance sometime in the future. And that's regardless of how you're exhausting, but if you're exhausting inside, it becomes even more important. And all this data, as we said, is going to help you improve and optimize those filter change intervals so you're balancing filter replacement costs and energy usage. All right, so next section, let's talk about compliance managing and reporting. So depending on what industry you're in, where you're located, there's probably some type of regulation about how that dust collector should operate and some data that you have to capture for the regulators. And even not a lot of customers who don't have that, they have internal reasons and internal audits that they need to capture data from. So I want to talk about how that process works and how it improves with a connected dust collector. So to start the discussion, I'm actually going to step away from the industrial world. We're going to talk about the trucking world and the electronic logging directive, which came out about 4 years ago. And some of you probably were pretty familiar. We had companies that this greatly affected if you've got trucking. But this was a massive change that affected over 3 million drivers in the U.S. It was a massive regulation that came down. And it said that if you're a commercial truck driver who has to track hours of service, those records have to be captured electronically. You could no longer use paper logs to fill in, when you're driving, when you're sleeping, when you're resting, so that you make sure you're in compliance with the federal regulations. So not only did it need to be captured electronically, it actually had to use a sensor on the truck so that it could track what the RPMs and speed were of the truck. So, and that's kind of the fail-safe there. You can't lie and say that you were sleeping if your truck was going 65 miles per hour down the freeway at that time. At least, hopefully, those two things weren't happening simultaneously. So they moved away completely from paper logs. And why did they do that? Well, they did that for a few reasons. But the main reason is it nearly eliminated the possibility that somebody is fabricating their logs, driving more often than they would. It also guarantees that regulators can get that data they can get electronic data. They can get it in a consistent fashion from whatever the trucker is. They're not trying to read different paper logs, and that those paper logs can't be lost or fabricated in any way. So this is a massive change. And I bring this up because these are the types of changes we're starting to see. And it's going slowly, but the changes we're starting to see in the different regulations people have around dust collectors. And obviously there's no, like there is with the FMCA FMCSA, when it comes to trucking, there's no one massive body that oversees all aspects of dust collection. So it's not going to be this type of sweeping change, but we are starting to see these types of changes in pockets and in regions. So as we discussed, paper logs are still pretty prevalent in the industry. This is how still a lot of customers track data that they need for management of their dust collectors and even for compliance. Somebody's writing it down, somebody's then capturing that data, grabbing those sheets, manually entering in a spreadsheet, and that's how the data is captured. And this obviously leads to a lot of challenges, similar to the challenges they were seeing with electronic logs in the trucking industry. It's time consuming, data can be lost, you can misread entries, and potentially fabricate, although hopefully that never happens, the data. Where if you look at it from a connected dust collector, and what you see is a graph out of our IQ system, that data is automatically captured, and it's automatically stored for up to a year. You can graph that data, you can export that data over any time frame. You know that if you have to produce that data because of a compliance audit, it's always there. And with one click, you can download the data from the sheet into a spreadsheet. So it really reduces the labor time. It really reduces the potential for error with the data. And most importantly, that data is there when that regulator is coming, or when that regulator shows up to do an audit. So we're seeing more and more regulatory agencies demand that data be collected this way and moving away from the filter log, from the manual written filter logs. Now, that's going to be very dependent on the country, the state you're in. Sometimes it even matters what county you're in, what your industry is, and then also whether you're exhausting inside or exhausting outside. Obviously, this is another thing to consider when we talk about the decision tree of exhausting inside versus outside, is how do your regulations change depending on how you do that. And it's largely affecting air permits is the main one, where you have to maintain differential pressure between a certain range to verify that your dust collector is operating properly, and you've got to record those differential pressure data and have them ready and supply them to an auditor should somebody show up. The other one that's starting to affect is emissions monitoring. So this is very often done historically with visual opacity checks. Somebody with trained eyes walks around, looks at the stacks, looks at the air coming out, determines are those particular levels starting to rise. That's the second one where we see starting to change. And the changes are that we see manual data recording no longer allowed. It has to be automatically captured. It cannot use a paper log. Visual opacity checks are no longer allowed. You need to use a sensor that's tracking the level of emissions, and that data needs to be automatically captured. It has to come from a sensor. It has to be automatically logged electronically, and then you have to be able to export that data for compliance reports. So some of you might have already been affected by some of these changes, but I think we hear it almost every couple of weeks. I feel like I hear a new regulation in some part of the country where they need a system like IQ to connect and capture that compliance data. So here's one example. It's probably the biggest one. For those of you in California, you might be familiar with the California AQMD mandate, Rule 1430. And what that specifically said is visual opacity checks no longer sufficient for checking emissions. This covered the metal cutting and grinding at different foundries, at foundries. So specific to that application. So you now have to use a particulate monitoring system. You have to have a sensor that's capturing data in real time. You have to get alerts should your particulate level start to rise, and that data has to be digitally stored so that you can export it and report it to a regulator. So this is just one example. Obviously, we're just affecting one region, one application, but we've actually seen a big demand for IQ in these types of applications because they can use this to capture that data and be compliant to the regulation. And I think we'll see more and more of these over time, and over time, paper logs will, in most industries, not be acceptable as a way to capture and report compliance data. So even if it's not affecting you today, it's something you might want to prepare for in the future. Okay, the last section we're going to talk about is how to track and manage emissions. So I'll bring back the graphic that we showed early in the presentation, and you'll see the 3 E's. And when we talk about dust collectors, we talk about the 3 E's of dust collection very frequently: exposure, efficiency, and emissions. And given the topic today, we're only going to focus on emissions. If you are interested in a real deep dive into the 3 E's, myself and one of our field service engineers did a webinar about a year and a half ago called Enhancing Your EHS Strategy with IoT Technology. We took a really deep dive into the 3 E's, what they mean, why they're important, and how to monitor that. That webinar is still recorded and available, so you can put that into its title and Google it, or if when we get my contact information, if you want to email me, I will send you a link out to that, and you can watch that recorded webinar. But for today's focus, because we're talking about sustainability, we're just going to focus on tracking emissions. It kind of ties into what we were talking about with the air quality mandate in California and not being able to use visual opacity checks. So we talk about monitoring particulate levels. There's different strategies or different methods to do it. The way it's done a lot of times is through a point-in-time measurement, which usually means you bring in an outside agency with this type of expertise and expert equipment. They will use specialized sensors, and they will determine exactly how much particulate is coming out of that stack, what your concentration is, whether we're talking about milligrams or parts per million. They'll give you an exact answer on that. And for a lot of companies, they're required to do that type of testing either annually or maybe more often. But of course, it gives you a really accurate answer, but it doesn't tell you anything in real time. In between those checks, you're still dependent on visual opacity checks or something else to alert you when those particulate levels are starting to rise. So one way you can do that and monitor in real time is using either a broken bag or a particulate trend sensor. And these terms mean different things depending on who you're talking to. But a broken bag sensor is typically a sensor that's going to give you a good, bad indication. It'll tell you if things are good, and if you have a catastrophic failure like a ripped filter or filter bypass, it'll send you an alert. But it's a digital sensor. It's good or bad. A particulate trend sensor works a little bit different. Is it's going to capture that data and show those trends in real time. So if your trend is starting to rise because your filters are old or maybe you've got a small tear, it can show you that trend. It can give you an early alert in some cases that you've got a problem with that filter, and potentially you can go out and track that data. It's not going to tell you exactly parts per million or total concentration, but it's looking at the trend. How are my emissions today versus yesterday versus last week? Now, the last one is kind of the Cadillac system of this, the continuous emissions monitoring systems. These will tell you concentrations. These are very complex, expensive solutions set up by experts, need to be calibrated. So some industries require this. Like if you're in power, you probably have one. For most cases, this is overkill for most of Donaldson's customers and most of our IQ users. You just really need to know what is that trend, and I need to get an alert when that trend is increasing. So if we go to the next slide, here's an example output from a particulate trend sensor on some testing we're doing internally, and you'll see that number is going to fluctuate a little bit over time, and that's natural. It's going to fluctuate when you're pulse cleaning, because as you're pulsing, there's going to be more particulate getting in the exhaust. And that's normal. But what this allows you to do is set a baseline. And you can see I've indicated kind of where the baseline is for that dust collector. And when you know the baseline, now you can set alerts if either it spikes or that average level starts to rise, either because your filters are getting very old or you've had something more catastrophic happen like a filter rip. So you can get alerts as it starts to rise, maybe potentially sometimes addressing the problem before it becomes a catastrophic problem. But even if you have that catastrophic failure, you're going to get an alert immediately, and you can send those maintenance teams out there to shut the dust collector down, fix the filters, change the filters, whatever you need to do. This is extremely important. Again, if you're exhausting inside and you have that type of incident, now you're pushing dirty air into your factory. If you're exhausting outside, now you're pushing dirty air and potentially polluting the environment. So monitoring that in real time is exceptionally important. All right, so just a few slides left, and then we'll get into questions. We should have about 10 to 15 minutes for questions on this as we're almost done. So if you haven't already, please put your questions in. So I want to just finish. We talked about the Donaldson IQ system as an example. I want to talk just a little bit about it before we close out. So our connected filtration service was launched about 18 months ago. We talked about how it works in the previous slide. What it's really doing is giving me insights to everything that's going on with that dust collector in real time. So we said there's a gateway on the device. It's sending data to the cloud and creating a web-based dashboard that you can view from anywhere on any type of connected device. You can also allow your partners to have access. So if you've got service companies that are helping you support your dust collector, they can also get access to it. So you can log in, you can see your data, you can get alerts if something is not acting normally. You can get the maintenance teams to be more to operate in a condition-based maintenance approach, so they're more proactively addressing those issues before you get catastrophic failures. If you've got compliance or you need to capture data, that data is automatically recorded, can be captured with one click, and it can also be graphed if you want to go back and debug certain things. So really provides benefits across, we've focused on just really the sustainability and energy, but it provides benefits to multiple different groups, anybody who deals with dust collectors in any way across the facility. So it really increases your maintenance productivity because you can move from a reactive maintenance to getting alerts and moving to condition-based maintenance. That can then lead to avoiding costly downtime. If you can address those issues before they cause a breakdown, or before they cause a massive labor and cleanup effort. Dust collector problems usually start out small, and they get bigger and bigger and bigger the longer they exist. So the earlier you can address those, the more chance you have any unscheduled downtime. And even if you have unscheduled downtime, the faster you can probably get that up and running and reduce that cost. We talked at length about managing EHS compliance reporting. We don't need to cover that again. But it also just generally helps you manage risk. And we've talked throughout this talk about all the things that can happen, the negative consequences from different dust collector incidents, from increased energy usage to dirty environment, dirty plants, exposure, regulatory fines. There's tons of them, and those are the things that really, more than anything else, customers want help with. They want to know that their dust collector is operating properly, and they want to know that if it's not, they're going to get alert or some information quickly so they can address it before a larger problem occurs. Okay. All right, in summary, so we really kind of focused on 3 points today when we talked about connected dust collector for sustainability and for EHS compliance reporting, measuring the dust collector energy use to improve it. So we talked about some techniques today, whether it's exhausting inside or outside, installing a VFD and monitoring compressed air pressure. Some of those things you don't need to connect your dust collector to do. But if you're not connecting the dust collector, as we've shown, like with the example of the VFD, you might not be getting those savings that you're expecting. And if you are exhausting inside, for example, it becomes even more important, more critical to monitor those things in real time. So to really get those energy savings and to prove that you're getting those energy savings requires connectivity. Automated data compliance and digital data for compliance reporting. So this is really one of the biggest factors that causes somebody to adopt IQ, because now they know that compliance data is there. They know anytime should somebody come up to audit them, they know that data is available. They don't have to dig through old sheets or deal with lost log sheets. They know it's there. They can export it with one click, and they can provide it to that regulator. And as we said, a lot of regulations are changing, and it is slow, and it's on a region by region, application by application basis, but they are starting to change that are requiring some type of automated monitoring, moving away from paper logs. And then lastly, that monitoring the emissions, understanding what's coming out of that stack, especially if you do visual checks or manual checks, understanding in between those checks what's going on with your emissions. So should there be any issues with your filters? Should they be getting old or there's been a filter failure or filter tear, you're alerted quickly. You can address the problem to minimize any type of damage potentially inside your factory or at the outside environment. And with that, I will conclude. So for more information, my email address is here. You can also see our Connected Solutions website or email connectedsolutions@donaldson.com, which is a generic email, and somebody will respond to your question. And the phone number for the Connected Solutions group is at the bottom. And so I will thank everybody for joining, and we will switch over to questions now. Stefan?
Thank you very much. It is now time for the Q&A session. If you'd like to ask your questions, just submit them in the box on the top right-hand corner. Type them in there and click Submit. Thank you very much. It is now time for the Q&A session. If you'd like to ask your questions, you can do so via the Q&A widget on the top right-hand side. Just type your question into the box and click Submit. But it looks like we have some questions coming in already. The first question for today is, How do you monitor the energy used by a VFD?
Sure, good question. So most VFDs have multiple outputs on them that are typically tied into control systems that will indicate, they're usually 4 to 20 milliamp outputs. They will indicate what power level the VFD is driving to. They may have other indications like what's the RPM, what's the overall current usage. So because the IQ gateway has inputs for optional sensors, analog sensors, we can tie those directly to the IQ gateway and report that data through the IQ system. And we can also configure the power range of the VFD, so you know exactly how many kilowatts you're using in real time, and then we can integrate that data to know how many kilowatt hours you use over a certain time, like a daily energy usage.
Thank you very much for that answer, Brent. And moving on to our next question. Can you measure energy on a non-VFD controlled fan?
Yes, you can. It would require an external current sensor, which again, we can read with our gateway. We can read just about any 4 to 20 milliamp sensor. So a current sensor on the power supply to the fan with the 4 to 20 milliamp output can be read and reported in the IQ system. You know, it's going to work a little bit differently. You don't have a direct relationship with a fan that's just on off, like you do where with a VFD, it's a pretty known relationship. As those filters plug, the fan's going to use more energy. That's not necessarily the case with a fan that's just on and off. So the data might be a little bit different.
Thank you for that answer. And just a quick reminder to the audience, you can still submit your questions through the Q&A widget. But moving on to the next question, which reads, how do you monitor exposure?
Yeah, monitoring exposure directly is hard to do. It typically requires bringing in some industrial hygienists and some professional services to track the air quality around your capture points. So it's not something we can easily do in real time. But where exposure is a concern, the most important thing is monitoring the airflow. So if you've got proper airflow, if your dust collector is properly designed and you're running at design flow, you can be fairly confident that you've got enough capture velocity at those hoods to pull dust away from the machine or from the workers. But what we see is as those filters start to age and they build up more pressure, eventually the fan is going to start that the fan cannot keep up and cannot pull air through the dirty filters, and your airflow is going to drop. And when that drops, you lose your capture velocity at the hoods, and now that dust is not being pulled away from your machines or people. So monitoring airflow and making sure you get alerts if that starts to drop is really important. It's not directly monitoring the exposure, but it is telling you, is your dust collector working properly and pulling the air and pulling the dust away at the capture points.
Thank you for that answer. And moving on to our next question, which reads, is IQ available in Europe?
Yes, it is. Yes, it is. IQ today is available in the US, Canada, and Europe. And we are planning to expand to other regions in the future. So if you have questions about another region, just let me know or email me, and I can give you an idea of when it might be available in your region if you're outside of US, Canada, or Europe.
Thank you for that answer. And just another reminder to the audience, you can still send your questions in via the Q&A widget. The next question we have here reads, is IQ available for non-Donaldson dust collectors?
Yes, it is. Most dust collectors have the same elements. You know, when we think about differential pressure, compressed air, airflow, so they all work about the same. So we can track the same data on just about any dust collector. Somewhere between 20 to 30% of our IQ installs have been on non-Donaldson dust collectors, and it's also available on brand new dust collectors and for dust collectors in the field. So you can retrofit your existing dust collectors, and you can also get it installed on new dust collectors before they even show up when they're getting installed.
Thank you for that answer. And we have time for one or two more questions. So the next one reads, what does the service typically cost?
The cost will really vary depending on how many dust collectors you're connecting at the plant. It's typically on a per dust collector basis. So each dust collector gets its own gateway. And so we charge based on the number of dust collectors monitored, and it's an annual subscription service. There's typically no upfront cost. So the hardware and the gateway are provided for free that first year of service. You're only paying for the annual subscription. I don't want to give exact cost numbers on the webinar or price because it's going to vary depending on how many dust collectors you have connected. But I would be happy to answer that over email if you want to send an email to me directly.
Thank you very much for that answer, Brent. And I'm afraid that's all the time we have for today. If you didn't get your questions answered today, please keep in mind they can be answered at a later date via email. So that just leaves me to thank Brent for what was a great presentation and to Donaldson Company for sponsoring this session. To the attendees, you'll receive an email shortly with instructions on how to watch the on-demand version of this webinar. Or you can do this on our website, which is www.business-review-webinar.com. Thank you once again, and have a great rest of your day.
Thank you, Stefan. Thank you, everyone, for joining today. Have a good day.